Good morning everyone. So what we are going to do today is we are going to solve the cantilever beam using ANSYS Workbench, where a particular kind of loading has been given on top of it and how the response will be for the steel beam. That is what we are going to design. Okay, so let's start here. So whenever you click on the ANSYS Workbench, it will directly open up to this particular section over here, and with this, as we are going to give the load, so first basically we have to go for a static structure. So why I'm going for static? Because I'm going to give only a static loading, not a dynamic one. So if dynamic loading, then separate transient structural has to be selected over here. So we will see that tutorial later, but right now we will see the static structural here. Click it and drag it over to here. So once you drag it, so you will get all the details. So let's change our name here. So Cantilever demo. Okay. So engineering data. Next step will be we need to collect all the necessary data that is required as the properties of the particular beam that is we're going to analyze. So double click it. So when you click that, the A2 engineering data will start open. So defaultly ANSYS will take as the structural steel having Young's modulus of 2 into 10 power 5 MPa, and the density of the steel will be 7850 kg per meter cube. So default material that the ANSYS is selecting is structural steel. So let us keep that way. We are not going to change the materials right now. So if you want to add any other material, so you can go into this particular option over here, engineering data sources. So when you click that, the whatever the sources or library of data ANSYS have will open automatically. So with that, so here that's the options that we have selected here, and on top of it that's the source or library of materials. So whenever I just click the general material, then whatever the material that are inside the general material will open up here. So as you can see, ANSYS have already selected structural steel as a basic element. So you can see it has a bookmark on this column C. So when you just hover your mouse over there, so you can see that it is used in A2 engineering data. So if you want to use any other thing, then just click the plus. So automatically it will come over here. Okay. Clicking another plus will not disable it. Okay, so just only you can add over here. You cannot delete it over here. So deleting option comes from here. So whenever you click add and add and add, things will get automatically added over here. So the structural steel is a default, stainless 1 and 2 I have added double time. Okay. So if you want to disable it, so just disable the engineering data sources and come to the engineering data and click the mark here, so that they will get crossed. And now you are commanding your ANSYS that these two materials you are not going to utilize, you are going to use only the structural steel. Okay, so that's how you can disable or enable any particular element and the properties of the element that you are going to analyze. Okay, so I have selected the structural steel here, so that's good enough. So as this portion is complete, you can see the small tick mark over here. So now let's go for the geometry. So in this geometry, so when you right click it, so you can see two options. So this is has been developed by ANSYS from ANSYS 18. So one is space claim geometry, another one will be design modular geometry. So design modular geometry was the basic one, in which you can customize it very each and every portion, and you can go in a slow by slow methodological way. While space claim will look like the modern modeling softwares. So you can model your geometry very easily if it is having a regular shape. So as I'm going to design for I section, so I'll go for the space claim geometry, because through space claim I can model my I section very easier. So let's wait. So majorly, if your system configuration is good, then this much of waiting time is adapted for ANSYS. If your system configuration is very high or even extreme configuration, then it will open very quickly. So basically the GPU, that is graphical processing unit, and also the RAM of your computer is much more used when dealing with all these FEM softwares, because they use up your RAM, they use up your GPU, they use up your processing, everything they will use so that you get the desired output. Okay. So now that the space claim has been opened, so we are going to design our I-beam here. So let's select this view. Okay, I'm going to draw my I section over here. Okay, and so there are some selection models and tools and all. You can easily create it or you can insert it. So right now I'm going to draw. Okay. So just picking some random numbers, so we can edit the dimension at a later stage, or you can enter the dimension there itself. Okay. So the best way will be changing the dimension then and there itself. Okay. So let me give 50, and here it will be so I'm going to use ISMB 100 cross 75 with the thickness of 10 mm. Okay, so it's 10 mm, 32.5, 10. So now that our I section is complete, so let's pull it up. So to decide length, the length of our cantilever beam which we're going to use. So there's a pull button here. So use it. So just don't leave the click and drag. Okay. And by just holding on to the mouse button, now give the dimension. So our length will be 1000 mm. So 1 meter beam. Our model is complete. Okay, so once your model is complete, just close it. Okay, so ANSYS is having its own space up, temporary space up. Whatever the model you have created, it will be automatically stored, and it will be used for the further stages. Now you can see the geometry is also there is a click mark on it. The next step will be model. Okay, so double click now the model. So your ANSYS mechanical will open up, and that is where we will mesh it, and we will apply the load, we will give the support conditions, and after that we will get our desired result of what exactly the nature of behavior that this beam is giving up for the particular kind of loading and support conditions, or in other words, simply the behavior of the material with respect to the physical conditions. So when dealing with all these things, the nature of physics should exactly match with the laboratory conditions or the original conditions. If they tend to differ, then what happens, you will get a different value, and that value will not correlate with exact values. So the nature of physics that you are going to apply on ANSYS should be as nearly as possible to the laboratory conditions if you are a research scholar, or to the exact site or working condition if you are a structural engineer doing some consultancy works. Okay, so right now our beam is ready. So these are the ANSYS mechanical one. So our model is here. So only this solid is here. So when you select it, you can see the assignment is structural steel. So if you have any other material, you can directly here, or you can define your own material by giving all the required properties. So coordinate system will be GCS, global coordinate system, and mesh. So mesh here I am okay. I'll give you a separate tutorial on what exactly the mesh qualities and properties of meshes and the different properties that we'll use or adopt in mesh. But right now what I will do is I'll just go for the automatic mesh that ANSYS option has. So I just right click and give update. So ANSYS will itself will give some kind of mesh. So after that, so now click static structure. So this is the option that we have selected on ANSYS Workbench at the beginning, and we are going to give only the static loading. So that is what this is the meaning of that. Okay, so let me rotate my structure kind of, so that I'll know where I'm going to apply the loading and where. Okay. So here, by selecting this structural, so and analysis settings. So here there are certain options that you need to pick here. So here large deflection, I'll on it. So what is exactly meant by here is, so whenever this is a cantilever beam, if okay, so what I will do, I'll just first switch it off, then I will show you the simulation, then I will tell you so that you can understand what exactly the difference is. Okay, so first let me static structural. In that first I'm going to give a force. Okay, so just the force, and where this force I'm going to provide, so it's defined by, so first the components I'm going to give it the top of this line, so selected, and vector, and let's change to component so that you can define it and which direction your loading will be basically. So as you can see, so our load should be in the direction of either positive Z or in the negative Z for our cantilever beam to action, because I have selected in such a line. Okay, so let me go to the Z direction, and in that direction let me give as 1000 Newton, or in the sense 1 kilonewton. If I give that, so now the loading is complete, and so if you select the load, then definitely you can see that the load has been applied. You can see the small red arrow direction that you can see, which indicates the load has been applied on it, and by the side you can see the value of the load that has been applied on it. Okay, then again click the static structural and click supports. If you have too much loadings, or if you give some more loadings, then you can go and adopt this kind of loading. Now go to supports, and as it is a cantilever, the other side is free and the only one side is fixed. Okay. So pick the one and select the A face, entire face. Just click it, okay, so that our one face is entirely fixed and the other one will be. And now our initial conditions are over. Now click the solutions, and what are the things we need? Total deformation, and we need stress. So after that, just right click the solutions and give solve, or you can directly press F5 as the keyboard shortcut to start the solutions for your physical problem. So once you give that, automatically ANSYS will take some time depending on how complexity of the physical problem you are facing. So the bigger the mesh, the less time it will take to solve. The smaller the mesh, the more time it will take. Okay, so that's the vice versa condition that you can use. So now you can see the total deformation. Okay, so it's 0.328 mm. So here only some very meager it is coming in. So let me increase the form over here. Yeah. So this 0.328 mm. So that's the minimum here, maximum here, and minimum is 0 because one side is fixed. Okay. And the stress, the maximum stress is 15.11. So that is exactly where the load has been applied. You can see over it. Okay. And the minimum will be the underside, because that's the phenomena where the load is applied. That's where the maximum stress is, and at the bottom you can find the lower stress. Okay. And at to the support will eventually get the higher stress. Okay. So now again let me go back to this analysis settings, and let me show you what the large deflection option will come. So here just remember we are having 0.328 mm as the maximum deflection value. But now let's go to analysis settings and select the large deflection value, and now again click solve. So now what you are telling your answer is that okay, this condition may undergo a larger deflection also. So if that's the case, then give the value for the deflection which may occur in a very bigger way. So that is what you are telling your your answers. Okay, so here also the same result. There's no change, but changes do occur when you are giving a finer mesh. So when you are giving a finer mesh and your structure is so complicated, and for example usage of nut and bolts, you're using double steps of loading, not a single step of loading, because what I'm telling is, see, on the force criteria, so directly in 1 second from 0 to 1000 Newton automatically it went, but in real case it may not be. In the load may not be applied in 1 second. The load may applied in either 1 second, after that it may get removed, and again it may be applied. So there are multiple steps in the provision of this static load itself. Okay. So if that's all the conditions that can come in, then definitely the value will differ when you come across with the large deflection pattern. Okay. So once you get it, so how you can even also get your video. So when you click that, the deflection profile will be updated and it will be exported as a video. So that's it for today. Thank you so much.